Hello, everyone. My name is Mike Hansen. I'm with Red Hat. I'm AVP of Open Telco Strategies, and in that role, I work with executives at various telcos around the transformation, not only to NFV, but really the open source transformation of the entire company. So I'm going to talk a little bit today about the Open Telco transformation, and I apologize on behalf of John Felton. John is a VP who's responsible for the infrastructure at Sprint. He was meant to be here and help me out. John's a brilliant guy and would have added a lot to the presentation. I'm very sorry he couldn't make it. But I'll cover the Open Telco transformation. I have a few slides at the end that John presented for Red Hat at Red Hat Summit that I'll share with you, give you an idea, a little bit about what Sprint was doing at that time. But unfortunately, I won't be able to really go into a lot of details about where Sprint is today. It's just not for me to say. All right. With the Open Telco transformation, you can see Glenn Lurie's quote there. That's the CEO of AT&T talking about open source. Very big deal. And we really perceive that in the future, a telco is going to be radios, cloud infrastructure, off-the-shelf compute and switches, and open source software. And that seems to be the trend. And what we're trying to do is help telcos get in a position to build toward that ultimate end goal and make sure that every step along the way you take toward that vision. All right? What we do is we take the same open source innovations that have made the FANGs, Facebook, Amazon, Netflix, and Google, and we bring those to the telco and we enable them to make the similar type of efficiencies that the FANGs use. Okay? So why is Glenn talking about open source? Open source, frankly, has been just proven to be a better way of development. History has kind of decided open source works better than proprietary. And so the power of the community, I kind of compare it to a Peloton. Peloton just has more efficiencies. You can have a breakaway, as this guy's trying to do, always looking back over the shoulder at the Peloton coming. And there's really, in the software industry, there's two kinds of breakaways. There's the companies that were already established, and open source comes along way back with their community. And they chug along, and at first the guy way out in the lead says, laughs at them. They're way back there. But the community always wins. There is no finish line. I mean, in a race, there's a finish line. And a breakaway can sometimes get across the finish line before they get caught. There's no finish line in technology. It just keeps going on and on. And eventually, the open source community efficiencies win. All right? Another way that we feel some companies make a mistake is they start with open source, and then they break away and they add their own proprietary features to open source. And the problem with that model is eventually they kind of diverge from they go down the wrong road to some extent. And then they have the problem of they tried to go this way, the community went that way. How do they get back with all the enhancements and innovations the community has done and get that into their product? So what we've seen is, in NFV in particular, a lot of people looked at OpenStack and said, hey, that could be a great basis for a Vim. And they took that and they made proprietary enhancements to it, and they said, okay, here's our open source, OpenStack-based Vim, right? But what Red Hat does differently is we're more like the group on the right over here. We work within the community, and we try to catalyze the community and really help lead the community or drive the community toward making OpenStack the best Vim, period. It doesn't need additional enhancements and extensions. We just want to build them into the product. And that's proven to work well for us. And so that's where Red Hat is in the industry and why we're doing well. But it's not just about the Vim. Basically, every software innovation today is being done in the open source communities. And within Telco, these are some of the important ones. OpenStack, of course, right? But a big part of a telco's infrastructure is analytics. They do analytics on everything. And Hadoop is open source. Red Hat doesn't support that version, but it's a very important part. All of the machine learning and AI innovation happening today, that's the upper left there. Those are all TensorFlow, Caffe. They're all open source. So as we get into AI and we start doing no-touch network management, closed loop automation, those will be important. But beyond that, even in VNFs, Metaswitch with their Clearwater project is IMS open source project. So that's the controller, the signaling system around voice services and other services like messaging. And then Sprint is actually open sourced an application that's really quite creative. It's the entire EPC, the digital core. So from the radio, you go into the digital core, and the digital core handles everything until it goes to the internet, right? And Sprint has the entire digital core in one package. It's meant to be used at the edge of the network for 5G. So what the digital core does is it enables you to put different components of the core in various locations, some at the edge of the network where the radio is, some at the center of the network where the internet is, and various places in between. What Sprint has recognized is when we go to 5G, everything will be at the edge, and you don't need to have all these different interfaces between different pieces of the core. So they built one core, one application they call it C3PO. It's very interesting. You should take a look at it, and I think it's going to be really valuable in the 5G environment. And Sprint has open sourced that. So it's not just the infrastructure, it's the other things that are coming with it. All right? So we really see three building blocks to the modern telco. And what do we mean by modern telco? Well, the modern telco is really going to be a platform for the development and distribution of digital goods and services, right? And it's really important, I think, for telcos to think of themselves that way. It's becoming an emerging digital economy, and the role of the telco is to grab as much share of that digital economy as it can. And to do that, we think there's really three platforms that are needed. One, of course, is the infrastructure platform that we're all familiar with. And the infrastructure platform, of course, transports the data, but it also generates a ton of data, right? Every layer of a network, the infrastructure, the hardware itself, the VIMs, the VNFs in that layer, they all report all kinds of telemetry back to the network. And network providers try to use that for managing the network. So it generates just about as much data as it transports. And then the other thing that NFV does is it allows kind of a transformation from mainframe to cloud era. I'll mention that in a minute. But it also delivers ROI through the reduction of vendor lock-in. And we'll talk about that a little bit more too. And then everyone's familiar with application platforms. You have to have an application platform. Let's take, for example, in any kind of application that's meant for machine-to-machine type application, Internet of Things application. You need an application platform for your partners or yourself to develop the application, obviously. And then you also need a place to run it, which would be the infrastructure. But you need to make sure that it's cloud native. So you have to have an application environment that's really modern. And we have OpenShift, which is our application platform. And it supports DevOps, continuous integration, delivery, all the great buzzwords of the day, microservices, and most importantly, it outputs cloud native code in containers, so you can run it really anywhere, right? But a more important, growing importance area is a data management platform. The amount of data coming from the devices and from the network itself is just staggering, right? Hundreds of petabytes in certain telcos, and it's only growing. So the data management platform's job is really to ensure that the right data is received and delivered to the right applications at the right time, right? So those are the three kind of platforms that we see as most important for the modern telco. And again, the modern telco is a platform for delivery of digital goods and services, all right? So let's move on to NFV a little bit, because I know that's the main interest here at the show. What is NFV? Well, NFV is quite simply, it really enables us to move the network from the era of mainframes that IT was in before to the cloud era in one jump. And what I mean by that is, in the mainframe era, you had dedicated hardware by one company and software bolted to that hardware. If you needed to make any changes to the software, you had to call the company, and they would make the changes if you paid them enough money, right? That's really where we are with network infrastructure a few years ago, before NFV started to come along. And what we're doing with NFV is we're putting the whole cloud infrastructure in place. We're separating the hardware from the VNF, the virtual network function, and we're really enabling the network to move into the whole cloud era, okay? Any questions on any of this? I'd be happy to answer questions in the middle as well. Okay? So here is Red Hat's cloud suite and also NFV infrastructure. And again, we didn't start off saying, hey, we want to build the best VIM, the best virtual infrastructure manager. We started off saying, hey, we've got OpenStack and we've got some other tools. Let's keep investing in those and bring OpenStack up, so OpenStack is the best VIM. And I think we've been reasonably successful at that. We have a pretty good market share in the VIM market. And I think the strategy of not separating and going after it as a separate product has been a good one. But what I want to point out here is that don't miss out on Linux. Linux is very important. It is integrated with every one of these products that are in the mix. We co-designed our Linux and our OpenStack and our Linux and our OpenShift, which is a container management platform. And it's really important that Linux and the higher layers in the stack are connected. Because if you have a failure in a higher layer of a stack because of a miscommunication with the Linux, you've got to be able to troubleshoot that and get it fixed quickly, right? We have, of course, a history of certifying applications as well as hardware. So we're used to being in the middle of that environment where software on the top and hardware on below, and we're able to kind of be the glue that allows you to support the entire stack. All right. We have the ability to run virtual machines, which is really where NFV is today. But many applications are becoming containerized, and we really expect the applications like IoT applications to be primarily containerized applications going forward. We do think that VNS will also migrate to containers, but it'll be a little slower than I think most people think. And I honestly believe that it'll be at least 5 years of a mix and probably at least 10 before you have mostly containerized network functions. So for a long time, we're going to need to be able to support both containers and virtual machines. And let's see, the beauty of this is we scale by adding x86 servers and commodity switches. That's all you have to add to expand your capacity. And we manage this all with CloudForms and Ansible. But of course, there's other ways of managing cloud infrastructure as well. That's just our management solution. And because we're certified on the top and the bottom, we can kind of be the glue that pulls that all together. Okay? According to, this is Del Oro Group, I believe, an analyst in the US, they predict that VNS will drive the cost of networks going forward. And the beauty of an independent NFVI layer, the software layer, is it creates an abstraction between the hardware and the VNF. And like in the mainframe era, no longer do you have to go to the VNF vendor for any changes. If another VNF vendor comes along that's more innovative or more cost effective, it's relatively easy to switch, right? So as take a 5-year cost of ownership model, for example, as the ability to cause your vendors to really compete for your business every day if you're a communication service provider, that ability will drive your TCO down because you can make them compete. You also make them innovate and be more efficient. So we really believe that the NFVI layer at 5 to 10% of the cost of a project is easily paid for by the return on investment you get from a more innovative set of vendors in the VNF environment, right? All right. So this is the three platforms, again, kind of more of a design of the way a network works. In this picture, the light blue is non-Red Hat products. The dark blue is Red Hat products. And of course, there are alternatives to Red Hat products, but since I'm from Red Hat, we put on all the Red Hat pieces. And one of the things that Red Hat does really is we create an abstraction layer. And this data management platform is another example of that, but let me give you the others. OpenStack abstracts the hardware from the software. And then OpenShift builds containers that allow you to abstract the application from the cloud that you've built. It could be an OpenStack cloud in your own data center. It could be Oz. It could be Amazon, or of course Amazon and Oz are the same. It could be Google. It could be any cloud that you can run Linux. You can run a container. So we've abstracted the application away from the cloud itself, so you can run those anywhere. And in this case, what we're doing with the data management platform is we actually kind of create an abstraction layer between the devices that are running in the network, maybe IoT devices, and the various network functions and hardware in the network, and we separate those from the applications themselves. So if you change out a device or you change out a network function, the data flow can still be the same. You don't have to update your application every time you change out a network function or change a device, right? So that's important going forward for the telcos, because obviously you can't be changing all of your applications every time you change something in the network, right? So what we have here is the same common management that I showed you before that includes the OpenStack platform, all of our management tools, which include Insights, Satellite, Ansible, CloudForms. And then if you just looked at the left side, that would be a typical NFV environment. There are devices, of course, that are feeding back to the applications, but the RF layer itself, the radios itself, have a ton of telemetry that they send back to the network. And each other layer does too. The EPC layer, that's the digital part, the IP part of the network. It sends that back. Signaling layer also has all kinds of information sent back, and the network services layer, of course, do as well. So the amount of telemetry that comes back to the applications, like OSS, BSS, for example, is really huge. What we really see happening is, in the future, there'll be zero-touch networks. And what that means is, for us, is we don't do the artificial intelligence. Those are coming, and they're coming fast. There's a ton of open source innovation going into artificial intelligence. But those all work on data, right? So what we're doing is really creating the nervous system. So we'll take the data and we'll make sure that the applications that need the data, like artificial intelligence applications that manage a network, get that data in the time frame they need it, all the data they want, when they need it, and at the right time. But then they will make the inferences on what needs to change in the network, find the root cause, and then we'll orchestrate a fix for them. So we're kind of the nervous system, they're the brain, right? So what we want to be able to do is make sure that when AI is ready, we can present all the data that the AI needs, and then we'll be able to orchestrate the revisions to the network that enable you to do a zero-touch network. There is a new Etsy group, like NFV started in Etsy 4 or 5 years ago, I guess. Etsy's now started a zero-touch initiative as well. So that'll be kind of the next buzzword as you go forward. NFV has been, and they're now looking at zero-touch initiatives within that. And you can have an AI application that's got all the capability in the world, but if you can't get at the data, it can't make a decision, right? So this needs to be run in parallel. You need to be building up this part of your network in parallel to building up your AI capabilities. All right. So the other part of the centerpiece is, I'm not sure how well you can see that from out there, but what we have is all the payload and telemetry being sent back to the application platform on the right. And there's really two parts to the data platform. So the top part is real-time messaging, and Red Hat's done a lot of work with the financial communities, the financial businesses, in particular the real-time traders who are trading on millisecond imbalances between two different markets. So they're very, very concerned about latency, just like the 5G applications are going to be concerned about latency. So that piece is real-time data flowing back to an application. And the applications in a telco network that might need real-time data, of course, IoT, if you're doing any kind of real-time adjustments on a car, for example. Obviously, you need very low latency and very quick decision-making on what we're going to do differently. There is OSS and BSS, the management systems that telcos use to manage their networks. If something goes down, you need to be able to respond very quickly to that. Then there's all kinds of applications that use Spark. It's just a variation of Hadoop that's typically used for real-time. Another area is security threat detection. If you have a denial of service attack or something like that, you need to be able to pick up the security threats very quickly and respond to them. So again, we're trying to be the nervous system for the AI that will come to be the brain for zero touch, all right? And then the bottom half is not necessarily real time. It's all that data will need to be stored. And in fact, AI platforms will need historical data to learn from and train and figure out, okay, when I see this pattern, this occurs. So there's going to be a need to retain all that data, and right now they're retaining a ton. A lot of you, how many of you have heard of data lakes? Yep. So many telcos and many companies are building data lakes, and they're typically using Hadoop. We found, working with eBay and a couple other very, very, very large Hadoop users, that at some point, the efficiencies of putting everything into Hadoop, it's more efficient actually to put into Ceph in its native mode. And in an Amazon cloud, for example, if you're doing Amazon analytics, the data is not stored in Hadoop. It's actually stored in its native object state. And then S3 is the interface that the Hadoop the analytics engine runs on. So the API to access the data is this S3 interface. And we emulate that, basically. So we build Ceph storage. We allow the Hadoop to attach to it using the S3 API, right? And it works exactly the same as doing analytics in Amazon. And that also enables you to store it natively so other applications can have access to it without having to use the Hadoop file system, right? So this is becoming the separation of the Hadoop from the data and the analytics portion of Hadoop has become really a big thing for the larger, I guess, more experienced users of Hadoop. All right, so we have that capability taken care of. I'm not sure you can read this, so I'll read some of it for you. On the bottom half here, in-memory storage, we can use in-memory storage for very high performance requirements. Typically at a telco, PCRF policy enforcement functions are very high speed and they need access to the data very quickly. They typically use in-memory storage. And then of course we can use flash and disk with Ceph as well. So we have the three tiers of different speeds of storage as required for various applications. Again, what we're trying to do is feed data in real time and then store data in systems that will allow other applications to access it as quickly as they need it, right? Make all the data available to all the applications all the time, all right? And then we also have the developer platform, enterprise application platform that helps, in addition to OpenShift, develop the applications. So I think if you think about an IoT environment, for example, this is pretty much your whole network, right? You have to have a platform to develop the application, the IoT application. You have to be able to run that application, and you need to be able to transport the data across to the devices, and you need to be able to manage the data when it comes back. An opportunity for telcos with IoT is today, most IoT applications, they have their own devices and they speak, one application talks to one device. A potential value proposition for telcos is to have all these devices that are out there feed data back to their network, and they store it and manage it and make it available to the applications that want it and actually pay for it, right? So by adding the information from, say, 5 or 6 different types of network devices that are IoT devices, you enrich that data and make it more valuable to the masses who will then pay for that data. And so the important piece here is the API management with 3Scale and kind of the governance around access to the data, because obviously a lot of the data is very sensitive, and you don't want just everyone to be able to have access to it. And you need to be able to bill for it and those type of things too. Okay? So that's kind of one of the use cases in the future that this type of platform to grab a bigger chunk of the value chain of the digital economy. As you all know, Google and everybody else make a ton of money off data. It's probably their most valuable commodity. And we think the telcos can as well. All right. The other thing that's clearly happening is 5G means that all of this is going to move to the edge of the network. You can't do real-time IoT and have, I'm from Kansas City, so you can't have a device in Kansas talking to a server in Florida, making decisions that are life-threatening or real-time, right? You need to have all the analytics, all the AI, all that information, all that capability needs to be at the edge of the network. So it's very clear that all of this will be moving out to the edge. So if you're a bellhead, anybody here from the old bell days? I don't think anybody. Okay, there used to be a 5 ESS switch that sat in a city, and that switch could act independently and be autonomous, semi-autonomous. As long as you didn't make it a long distance call, you made a local call, that switch could operate fine. It would only need to talk to the network if there was some long distance requirement, right? What we think is going to happen is the cellular network is going to become, in 5G, like the 5 ESS switch in the old wireline days. And that'll be an autonomous little network, a semi-autonomous little network at the edge of the network that as long as the traffic is within that network, it can function just fine. And it only sends traffic or trunks traffic outside of that little node as needed. And also there's going to be some management requirements as well. Okay. In particular, the HSS, you'll write to a centralized HSS, but then have copies of the information at the remote sites. So you can access the HSS very quickly at the remote site, but you need one standard HSS to be fed to. All right. So that's really all I have on the open telco model. And we're going to have John really update you on where Sprint was in the path. And I'll share the slides that John shared at our Red Hat Summit with you and give you some idea of what they're doing with Red Hat. This was Red Hat focused, not NFV focused, because it was Red Hat Summit. So I apologize that I don't have John here. He would have been, he's an excellent presenter and very, very bright, and would have been able to answer a lot of your questions, I'm sure. But I'll do my best to cover his material from the Red Hat Summit. Of course, they use Red Hat Linux, and here's some of the bullets he had. Over 7,000 images running on x86. He likes their support. I think he thinks his Red Hat support team is extremely handsome and capable and charming. But the CloudForms is used at Sprint. CloudForms is our management platform for not only OpenStack, but we can manage VMware environments and everything else. In fact, CloudForms was originally a third-party VMware management tool that was better than VMware at managing VMware. And Red Hat bought that and then expanded its use beyond VMware into OpenStack and other environments. And so they use that and like that as well. They've purchased the OpenStack platform, which is probably the thing that most of you are interested in. And it's their Vim solution for NFV. And they use Ansible as well for automation. They are deploying to 30 plus Red Hat OpenStack, well, 30 plus of our OpenStack platforms are being deployed for VoLTE. And VoLTE is really the entire network, right? It's the core, and it's the IMS platform for signaling, and it's also the servers for voice and the telephony application servers for voice and messaging and things like that. So it's really the network that they typically deliver. And they're deploying that to 30 sites today. I know they don't have any live traffic on it right now, but they're working on that. They're using DPDK, of course, and they're also, as John mentioned, using Ansible Tower for automation. All right. They see a lot of operational benefits. I'm not really going to go a lot into this. He was being kind to Red Hat because it was a Red Hat summit. But obviously they get value out of their Red Hat subscriptions, as I hope all of you do. Okay, so with that, hopefully there's some questions I can answer. Anyone? Lively group. All right. You sure there's no questions? We can wrap this up 7 minutes early. All right. Thank you all.